Well, hello, my algebros. This is the second part of what we're doing. We did 3-3 part 2, and now we're looking at graphing functions. Graphing functions. How can you use a table to graph a function? Well, let's check it. We did this already on crossing the river, but let's do a little bit more practice, shall we? So if I have a table, like so, and I have my x values, which I also know as my inputs, and my y values, which I also know as the output. I can put some different numbers into our function, right? So f of x is our output, and x is what we put in. So we're going to graph f of x when we have 2x plus 1. So we'll just grab a couple numbers here, right? We can pick anything and plug it in, but I'm just going to go ahead and go with 0 because it's so easy, right? It's so easy because x times, if I make x 0, then anything times 0 goes away. It's just going to be that other value. We also call this a y-intercept because it's going to hit on the y-axis. Yes, on the y-axis. So 2 times 0 obviously goes away, and we just have that it's going to be 1. So when x is 0, the y-intercept, or known as the value here, is going to be 1, right? And I'm going to try another easy one. Anything times 1 is itself, so I'm just going to go ahead and try 1. So if I have f of 1, when x is 1, my y value will be 3. And it only takes 2 good points to draw a line. 2 good points, right? Think about it for a second. If I have 2 good points, then I can have a straight line, right? So I'm going to go ahead and graph these points of 0, 1, which is also known as a y-intercept, and 1, 3. And I use a straight edge or a ruler to connect my dots and continue, and making sure I keep some arrows on there, letting everybody know that this line continues with all of the solutions. So how would I graph something like this? Well, I want to go ahead and first solve for y. So I add x to both sides. Seeing why we had to solve all those equations. Yep, it's true story. And now I'm going to divide by 2. And I have to divide everything by 2. And if I'm dividing x by 2, it just means 1/2 of x, right? And 6 divided by 2 is 3. Now I can make a table if I wish. And I grab some points here, right? I often like to use 0. And then I'll just use 2. And because it says 1/2 of x, I'm going to pick an even number because I want to make my life easy, right? So I'm going to have to cut it in half. So why not pick an even number? If I pick an odd number, I end up with an improper fraction. So I just want to go ahead and pick an even number. So I can cut it in half and add 3 to it. So half of nothing is nothing, right? And so that's just going to be 3. We also know that as the y-intercept. When x is 0, y is 3. And that will be on the y-axis, right? Because there's no x value. And when x is 2, well, half of 2 is 1, and 1 plus 3 is 4. And then when x is 4, half of 4 is 2, and 2 plus 3 is 5. Easy peasy, lemon squeezy. Now we have 3 good points to graph on here. We have a y-intercept, right? And we have all these points. 0, 3, 2, 4, and 4, 5. Let's go ahead and graph for this function. Now I see that this is squared, and this tells me right away, because it is squared, it will be a parabola. It'll be a parabola. So when I graph something that's squared, I need some positive numbers and some negative numbers in order to see what this graph will actually look like, right? So I know that y is going to equal x squared. I make a table, and on things that are squared, I like to use -2, -1, 0, 1, 2, making 0 in the center because it's going to show my vertex or the center of this curved line. So I just go ahead and plug it in. So -2 squared is, 4. And 1 squared is 1. 0 squared is just, 0. 1 squared is still 1. And 2 squared is also still 4. So notice that we have repeating numbers in here, and that's okay because x values are not repeated. It's okay that y is repeating, but x is not, right? It still makes it a function. So I go ahead and graph these points, and look at me, it's a happy face. And you could tell that because in front of the x squared, it was a positive number, meaning it's smiling at you. If it was a negative, it would be sad. You'd be frowning. Let's look at this one, an absolute value. Absolute value equations have a certain look about them, just like our x squared are always curved, making a happy or a sad face. A absolute value is always shaped like a V, either a positive V or a negative V. And again, I want to have 0 in the middle, -2, -1, 0, 1, 2. I solve for these. The absolute value of -2 minus 1 is -3, which would be 3, right? And again, -1 minus 1 is going to be -2. Absolute value of -2 is just 2. 0 minus 1 is going to be -1. Absolute value of -1 is 1. And 1 minus 1 is 0. Absolute value of 0 is just still 0. And 2 minus 1 is 1. And that would be absolute value of 1 is 1. So I see again some repeating numbers, and that's okay because y can repeat, right? It can have more than one x, but x cannot have more than one y at a time. Now I'm going to go ahead and graph these points, and I'll see it makes a V. Yep, makes a V. Go ahead and try this one. See how you do. Pause the video here, and then check your work. Does your graph look like this? Well, I hope so. A couple things I want us to learn from this is that see this little negative, see this little negative line, -2 right here, shows us it was going to be a negative line pointing in that end direction of a negative. And it also ends negative here. Just saying. Our y-intercept, or when x is 0, is 2 right there. And we can see that it would be 2 right there. So we'll look at that more next time. We're going to do some graphing vocabulary and practice, and I'll be giving you that on a PDF in class. Alrighty, have a wonderful day.